I'm Dr. David Carlson. I'm recently retired. I was the chief scientist at BP Solar for, like, about the last dozen years. And before that, I was the vice president of Solarex. As chief scientist, I had a bundle of money that I was using to support advanced research in solar cells. And some of the funding went to exploratory work in various types of new types of solar cells. Some of it was for advanced silicon processing. And in looking at what interesting work was going on around the world, I began to realize that there was some exciting stuff going on in Europe, in Germany, with laser processing, as well as in Australia, University of New South Wales. So wound up giving some financial support to some organizations that were doing laser processing. And the work proceeded very well. They made good progress. And we set up an internal group and started doing some work internally within BP Solar in the last several years. So I personally have become convinced of the value of laser processing for photovoltaics, and that I believe you can get high performance solar cells at low cost using lasers. Lasers are useful because they can replace furnaces for one thing. You can apply the heat locally, only where you need it, so that you can, for instance, make point contacts or selective emitter contacts, and make the contacts only in very small regions and do it very, very rapidly. So there's no need for large furnaces. There's no vacuum processing. So in principle, you can do solar cell processing very, very fast with relatively low cost equipment. The lasers nowadays, especially fiber lasers, are quite cheap. So I think there's the potential there to totally revolutionize the way solar cells are made. Instead of big systems that require vacuum and that require high temperature, large furnaces, you can replace a lot of that with lasers. The efficiencies today that you can do with laser processing are really quite remarkable. Like Fraunhofer's made almost 22% cells with laser-fired back contacts, I think 21.7 actually. So that's a very impressive demonstration of what you can do with just firing aluminum through a dielectric for a point rear contact. But there's been some recent work out of the University of Stuttgart, for instance, where they've made, I think, close to 19% cells, where they've made an entire solar cell emitter, front surface emitter, by laser doping phosphorus into the silicon. And so this proves that you can make very high quality junctions using a laser. So those are examples of where previous to that work you'd have to use high temperatures and special types of printing techniques and so forth to make these types of contacts. They've been done entirely with lasers. So I think this is just the beginning of what can amount to a whole new way of making these types of cells and more advanced solar cells in the future. And one point I think it's important to emphasize is that you have a lot of technology development in solar energy, in photovoltaics, but there's a lot of technology development going on in the field of lasers, and that really has tremendous impact because the cost of the lasers are coming down. They're becoming more powerful. The laser systems are becoming more versatile. And that's what's enabling us to do a lot of things with solar cells that you couldn't do before. In solar energy, what you have is a lot of companies using lasers to scribe or do the interconnections for thin film solar cells. They're used for, I think, all the thin films in part of the interconnection for amorphous silicon cells, cadmium telluride solar cells, and even for CIGS cells for some of the interconnections. So that's certainly one of the very biggest applications. Actually, lasers have been used for a couple of other applications too, commercially. One is just some companies are using now for identification of modules and cells, marking, laser marking. Some companies have been working with laser isolation, edge isolation, but actually it turns out that's probably becoming less common now as some of these other techniques, chemical techniques, improve. And then another technique that had been used by our company, BP Solar, was actually using laser grooving for what we call the Saturn cell. This was basically a selective emitter type solar cell, which for several years was the highest efficiency cell on the market. But basically, costs came down so fast that was sort of left behind. It became an obsolete product just because it was too expensive to make the way we were making it, so it was discontinued. So there's a state of flux. Lasers aren't widely used today, especially in the crystalline silicon business. But I think the potential for them is enormous, and for the reasons I mentioned earlier, I think you'll see a number of new techniques like laser doping, laser firing of contacts, which is a form of laser doping, laser ablation, possibly laser texturing, laser transferring of contacts and of dopants. These are all relatively new techniques that I think will, some of them stand a very good chance of being commercialized in the next few years.